Konnichiwa. Welcome to Chocolate with Ed Garcia. The best part of Chocolate with Ed Garcia is eating chocolate with Ed Garcia. Today we have strawberry, oishii, strawberry chocolate by Meiji, Japanese chocolate. Strawberry is one of my favorite. Open it, bring it near your mouth, ready, go. Delicious. Let's do it again. Let's have another simultaneous chew. Ready, ready, go. So delicious, so delicious. Okay. Today we have speech 16 reference characters and big hammer. You will love the big hammer. Here we go. Here are the contents of what we're going to cover today. We're going to cover hammer types. There are 4 types. We're going to cover BFH hammer definition. Very important that you know what a BFH hammer is. Okay, follow up. We're going to talk about speech 15 briefly regarding bad images. We're going to talk about figure 1 annotated, errors, the big hammer guidelines, figure 1 assemblies, figure 11 colored figures, old, and new figure 11 with the hierarchy. And then we will have a summary. Here we go. Hammer types. How many types? 4 types of hammers. The first type is a small hammer. Ding, 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 ding. For very, very small nails. Okay. Hyaku yen at Daiso. It's about as big as my finger. Ding, ding, ding. 8-ounce hammer. So 8 ounces, 1/2 pound, 227 grams. We have to go metric, right? We're in Japan. Let's do some metric. The second hammer is the standard hammer. This is the most common hammer. Standard hammer. Ding, ding, ding. Okay, this one hurts. Ding, ding, ding. 300 yen at Daiso. This one is not high quality. But this is the standard hammer. I used this for many, many, many years. A standard 16-ounce hammer. And what about the BFH hammer? Some people call it a big hammer. This is the big hammer, 22-ounce. And you see how big it is. You can hold it with 2 hands, whack, whack, whack. We sometimes call this a framing hammer. See the knobs here? That catches the nail so the nail doesn't slide when you hit very hard. Punk. Many people use this when framing a house. A 2-inch by 4-inch board, nailing those together for the framing of the house. Now, when I was young, I thought, I don't want this big hammer. It's too big. It's too heavy. I would use this medium hammer, tink, 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 and maybe I have to hit it 2 times, but now I don't have to carry this. Well, as I got older, I learned that I was wrong. This hammer is not big enough because if you hit a big nail with this hammer, most of the energy just goes to beginning the nail driving. So the nail only goes a little bit. So you have to hit it boom, 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 maybe 5 times to get the one nail in, right? But if you use the big hammer, the BFH hammer, and you hit that nail, you can hit it once and it goes far. And maybe you hit it a second time just to finish it. So this works much better, much better. BFH. This is a BFH hammer. It's a big hammer. And of course, the fourth kind of hammer is the MC hammer, okay? MC hammer. MC hammer. Okay, continuing. What is a BFH hammer? A BFH hammer is a big fucking hammer. This is a big fucking hammer, okay? When you're serious, you want a BFH hammer, a big fucking hammer. Okikuso hama. Okikuso hama. Did I say that right? Okay, when you're serious about hammering, this is what you want. Okikuso hama. Pa, pa, pa. Here we go. Okay, I want to follow up on speech 15 for a little bit. Recall, speech 15 was an examination regarding bad images on a Makita application 16597-304. I did a sample of 10 Makita applications around this period of time, and 2 of the 10 were bad images. Okay, so it looks like perhaps 20% of Makita applications have this image problem. Previously I said it was a compression-decompression problem. I've learned more about this problem. Probably this is a translation issue from one type of PDF, portable document file, into another type of portable document file. And then this is submitted to the patent office, which may convert it again into yet another type of portable document file. So it looks like this happens when there are 2 conversions from portable document file program A to portable document file program B to portable document file program whatever the patent office is using. So previously I was talking about compression, decompression. This is very related. 20% are bad based on my sample. As you recall, this is figure 1 of that application. And I put in annotation, the names of all these parts. And you know what? These parts, most of them do not matter to this application. So all of these numbers in figure 1, they are noise. Noise. It distracts from the application. It distracts from the invention. Additionally, it creates many problems. For example, well, please watch the previous speech, speech 15, for all the problems that this creates. Not good. Now, specifically, there were 5 problems. Now, let's talk about the big hammer. This is the theory of the big hammer. When you have a problem, don't start with a little hammer. Ding, 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 ding. Oh, that didn't work. Maybe you bend the nail, you waste some time, and then you go to a medium hammer. Ding, 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 ding. Oh, maybe it works, maybe it doesn't work very well, but you just keep hitting it until it finally goes in, and then you go do something else. No, 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 no. Go to the big hammer. Go directly to the BFH hammer. Boom, boom, boom. Plan on the problem being more difficult than you anticipate. Because when you begin, you think, oh, it's going to be easy. I'll just use the tiny hammer. Ding, 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 ding. I'll use reference character with 1 digit. 2, element 5, element 7. And then later you find out, oh no, there's more elements. I need element 23 and element 28. So you go to the medium hammer, 2 digits. Element 38. And then, oh no, there are more parts. I need to go to 38A, 38B, 38C, but now see, you started with the little hammer or the medium hammer, and you realize that really this was a big hammer problem. And this application is a big hammer problem. You want to approach it seriously. You want to smash it with a big hammer, okay? Big hammer. Now, specifically, 3 numbers, 3 digits in the reference characters. 1, 2, 3, okay? Not 8 and 9. Let me tell you another problem with single digits. When you search for a single digit 8 or 9, it's hard to find, okay? When you do the find function on a Word document to try to find what 8, where 8 occurs, you get it everywhere. You get it in 23, you get it in 87, you also get 8. You get paragraph 0008. Very bad, very bad. Now, use hundreds for the assemblies, okay? 200 is an assembly. 300 is another assembly. So one group of parts is 200 through 299. Another group of parts is 300 through 399. See? Assemblies. I will explain. Now, there's an exception. Exception for machine 1 or device 2. Something like that. There's reasons for it. It's kind of subtle, but trust me. So the overall thing, if you call it a machine or a device, one character, one digit, such as 2, device 2, that's good. You don't have to say device 200. So save the 3 digits for assemblies. Continuing. You do it like this. Let's look at the hierarchy. 200, 210, 212, 212A, 212A2. If you use this hierarchy and you start with the machine 1 or device 2, that gives you 6 levels of hierarchy, okay? Level 1, the whole thing, the global, is 2. That's one level. The assembly, 200, that's another level. 210, maybe a sub-assembly or something, is another level. 212 is a 4th level. 212A is a 5th level. And if you need to, 212A2 is a 6th level. So here's a good system for 6 levels of hierarchy. Okay? 6 levels of hierarchy for your machine. Should be enough. Some exceptions. Letters may be used with a minimum of 2 letters. For example, AX1 for an axis, CL1 for a center line, CAP1, cap1 for a capacitor, AA or BB for sectional lines, okay? Don't do this. Don't do surface, S, one letter, S, or center line, C. No, don't do that, because if the examiner or a future attorney wants to search the document using the find function of Word and he types in one letter, A, there's too many results. You don't want that. Now, some other suggestions. Do not use dashes. Dashes cause problems. Dashes or hyphens. If you want to strike through something when you're making changes, it doesn't show, it causes problems. Similarly, don't use underlines. Do not use small letters like small a. Do not use single letters like the letter S. Okay? Don't do these things. Bad technique. Bad technique. Continuing. Now, figure 1 should show all of the assemblies if possible. In this case, figure 1 should be this figure because it shows 4 assemblies. We have the device 2 and we have 4 assemblies, and notice they are from front to back. 200 is the harness assembly. 400 is the support plate assembly, which is attached to the bottom part of the harness assembly. Back plate assembly, 600, is here, and that attaches to the top part of the harness assembly, as you will see. And last but not least, 800 carried assembly. What are you going to carry? This thing over here, perhaps a leaf blower, for example. Carried assembly or carried tool, something like that. So these are the assemblies. There are 4 assemblies. Claim 1 probably should only include the support plate assembly and the back plate assembly, because these 2 assemblies interact in a sliding fashion like this. Right, the back plate assembly slides up and down relative to the support plate assembly, and they're contacting each other, and they're locked together with a lock mechanism. So, okay, figure 1 should show the assemblies. Don't give me figure 1 with 30 sets of character references. I don't want it too much. Give me the big picture. Now, you might want to repeat this figure later with more all of these elements shown that I've erased from this figure. Okay, it's a nice side view of many of these things, but not in the first figure. Okay, the first figure should just say the big picture, the assemblies. Next, this is from the previous speech, and we have a colored figure 11, and notice the numbering. Try to find hierarchy in the numbers, and the answer is there's very little. Now 82A, 82B, so there is 82A and B are clearly similar things, a right and a left. And here's another one, 82C, 82D. So that's some hierarchy there with 82. But what does 82 belong to? 82 is a subset of 60, right? 60 is the back plate. What? All right, if you look at this, how do you know that these engagement holes, 82, A, B, C, D, are parts of back plate 60? And the answer is, well, you can tell from this figure, but you cannot tell from the numbers. And then this thing down here, support plate 62, is also, for us, it's an assembly. It is support plate assembly. And it includes things like 84, 84B, 99B, 104. Just by looking at these numbers, we don't know that they are part of the support plate. Now, when we look at this figure, we can kind of understand, but later when we describe it using numbers in a detailed description, we don't know, we don't remember. We're not including hierarchical information in our naming conventions for the reference characters, okay? We're not doing a very good job. We're doing an okay job. These are clearly numbered, but they don't show the hierarchy, okay? I'll show you a better way to do this, which is like this. Now, consider the description of figure 11 could begin with this sentence. See the quotation mark? Watch this. Figure 11 illustrates 400 support plate assembly, okay? And then indentation, 410, we could say including here, including, whatever. 410 lock mechanism. The lock mechanism includes 412 support pin and 414 latch, okay? Look at the hierarchy. Lock mechanism is a subset of support plate assembly. Support pin and latch are subsets of the lock mechanism. Nice, okay? Crystal clear, very good. Sometimes Japanese do this a different way. They will say, for example, support plate 4, and then lock mechanism 41, support pin 412. And that's acceptable, but it's not as good as this because of the difficulties with single-digit reference characters. Also, when I've seen Japanese applications do what I just said, for example, support plate assembly 4, lock mechanism 41, you see the hierarchy, support pin 412, okay? So when they go one more level of hierarchy, they add one digit. That's interesting. But the difficulty is when they create a list, it goes, the order gets mixed up because you would have back plate assembly 6. So you'd have support plate assembly 4, back plate assembly 6, lock mechanism 41, something else, right? So it's, if you do it numerically in ascending order, then you lose the hierarchy. Okay, continuing. So now look at the bosses. I could have introduced something called 420 for bosses, but I didn't. I just said 422, 424, 426, 428 are bosses. So 420 would occur in this hierarchical location. And then subsets of these are 422, top right boss, 424, top left boss, 426, bottom right boss, 428, bottom left boss. Now these bosses are not important, but I go through this level of detail to emphasize that how to do it in a very clear fashion. Additionally, with each of these bosses, there's a screw, and I just add an S to these. So 422 top right boss has a 422S screw associated with it. So this is one way to use letters to help you remember things. There are other ways to do these things. For example, let's talk about the back plate assembly 600. So notice everything here starts with a 6. All of these things are back plate assemblies. All of these things down here start with a 4. They are support plate assembly things. Now back to the back plate assembly 600. It includes 612, 614, 616, 618 engagement holes, these holes here, and they have names. For example, 612 is top right engineering hole, 614 is top left engineering hole. There are ways to use letters to carry this information. If you use letters, in this case, in the reference characters, you can carry that information more clearly. For example, 610, instead of 612 for top right engagement hole, you could call this 610 TR for top right. And you could call this one 614 top left engagement hole. You could call it 610 for engagement holes, or 610 TL top left. Bottom right, BR, bottom right, BL, bottom left. So you can use letters to describe the position, 2 letters to describe the position. Or you can do similar to what the original application did and call them A, B, C, D. By the way, this is very interesting, right? A, B, C, D. It doesn't go in a circle, it goes A, B, C, D. Left to right, bottom left to right. It's interesting, like reading a book. Okay, one more thing of interest here is the lock mechanism 410. which is here, lock mechanism 410, includes two parts, at least two parts, 412 support pin, 414 latch. Now, I took this lock mechanism and I defined it as part of the support plate assembly. Another possibility is to define it as a separate assembly, as for example, 500 lock mechanism assembly. And that would be fine, that'd be very reasonable. I considered doing that, but I didn't. Okay, continuing. So, to summarize, 3 characters, hierarchical numbering of the reference characters. Isn't this nice? Isn't this nice? I can tell you a number, 627, and you know, 627 is part of the back plate assembly, and the 2 tells you it's going to be a latch. The 6 back plate assembly, 6.2 is going to be a latch in the back plate assembly, okay? 6 gives you information, 2 gives you information, and the 7 a more detailed information. Okay, here's a summary. Big hammer. When should you use a big hammer? Well, if you have one patent, it doesn't really matter. You can use a little hammer, you just want to get it finished and move on. But if you're Makita and you have 1,000 patent applications over a 10-year period, you want the big hammer, okay? You want to do a very good job of creating detailed assemblies with hierarchical reference characters. So, if you have 1,000 patents, then you want a super specification or a master specification that serves as the basis for all applications of that type of machine. In this example, a later invention with a new harness assembly 200 should require at most changes to the harness assembly 200 features and possibly changes to associated portions of the support plate assembly 400. For example, Makita has many drill type applications. So creating a very good application with very clear assemblies should save you a lot of time when you write the next application, okay? Continuing. And probably I will try to create one of these later. Not yet. So, this was Chocolate with Ed Garcia, Speech 16. Reference characters, especially Big Hammer. This was the best speech ever. The best speech ever. Yes. The best speech ever. Why? Because we had chocolate, we had a hammer, a big hammer, and you're not going anywhere until we talk about Mount Fuji. This is water wheel at Onden. Onden no Suisha. Onden no Suisha. Of course, here's Mount Fuji. And here are some people. I think these people are taking some grain to be ground, smashed by the wheel inside of the inside of this area over here. By the way, my grandparents lived in Cuba, and they had a sugar plantation. So they had a wheel to grind the sugar cane, smash the sugar cane and get the liquid out, and then dry the liquid and make sugar. How about that? So this is a Japanese water wheel, and let's zoom in. Let's look close at part of this. here's a lady with her basket, I guess, for clothing, maybe. She was washing her clothes, but it looks empty, so I don't understand. I don't understand what she's doing. Where are the clean clothes? And this little boy has a turtle. Can you see the turtle? And he's pulling the turtle towards the water. He wants the turtle to swim in the water. Very nice, very nice. 日本が大好きです。日本が大好きです。日本が大好きです。ありがとうございます。さようなら。バイバイ。